So the first one says practice using Kramer's rule. What is Kramer's rule? What do we have to do? So we're solving the system of equations, but what specifically do we have to do here? Awesome. We set it up as the matrix, and this is the one where we have to find the discriminant of each part. So we have to find our discriminant of the coefficients, our d sub x, our d sub y, and our d sub z. So we set it up as a matrix first. So we're just looking at the coefficients of x, y, and z. So what's our first row? Our coefficients of our first equation.
1, 1, 1, 1.
1, 1, 1. What's our second row?
1, negative 1, 5.
1, negative 1, 5. And our third row?
5, 1, 1.
5, 1, 1. So we're just finding the discriminant of our coefficients now. How do we find the discriminant of a 3 by 3? What do we need to do? The determinant. The determinant. What do? We repeat the first two rows. So we have 1, 1, 5, 1, negative 1, 1. When rewriting the first two rows, just make sure you don't do any silly mistakes here. Make sure you're just rewriting those exactly how they are. Now we have to find the sum of the majors and then the sum of the minors. So what's 1 times negative 1 times 1? Negative 1. 1 times 5 times 5. 25. And 1 times 1 times 1? 1. So negative 1 plus 25 plus 1 is 25. So now we need to find the sum of the minors. So 5 times negative 1 times 1, negative 5. 1 times 5 times 1, 5. And 1 times 1 times 1 is 1. So we want to add these three numbers together first and then subtract it from our major. So negative 5 plus 5 plus 1 just leaves us with 1. So we have 25 minus 1, which is 24. All we do for the numbers on the outside is just repeat the first two columns. So we just rewrite them on the outside. All right, next we need to find d sub x. So what's the one difference here to find d sub x? What do we have to do? Awesome. We put the answers in for x. So whatever our little subscript there is, we have to put the answers in that spot. So in the x column, we have negative 1, 5, and 19. So we're just putting these answers in our x column. Everything else stays the same as the original. So we just rewrite our coefficients for the y column and the z column. So we have 1, negative 1, 1, 1, 5, 1. And then what's the first thing we need to do to find the determinant? What do we do first and the last one?
Rewrite the first two problems on the outside.
Rewrite the first two columns on the outside. So we have negative 1, 5, 19, 1, negative 1, 1. So just like before, we have to find the sum of our majors minus the sum of the minors. So our majors are these three diagonals. So we have negative 1 times negative 1 times 1, which would give us what? Positive 1. Then 1 times 5 times 19. $95. And 1 times 5 times 1 is 5. So our sum of our majors is 101. Now we need to find the sum of the minors. So 19 times negative 1 times 1 is negative 19. 1 times 5 times negative 1 is negative 5. And 1 times 5 times 1 is positive 5. So negative 19 minus 5 plus 5 is just negative 19. So minus negative 19. What is 101 minus negative 19? Awesome.
120.
120. So this becomes plus. So our d sub x is 120. Everybody with me so far? Any questions? All right, now we need to find our d sub y. So what do we need to do different here?
You put the answers in the second column.
Awesome. We put the answers in our y column, so the middle column. So we have negative 1, 5, and 19 in the middle. And then our x column and our y column, our x column and our z column stay the same as the original. So we have 1, 1, 5, and 1, 5, 1. Now how do we find the determinant? What do we have to do first? Rewrite the first two columns. So we have 1, 1, 5, negative 1, 5, and 19. Just setting this up is where I see the most mistakes. So just make sure you are careful with what numbers you're writing down. So we multiply our majors and add them together first. So we have 1 times 5 times 1, which is 5. Negative 1 times 5 times 5 is negative 25. And 1 times 1 times 19 is positive 19. So what do we get when we add 5 minus 25 plus 19? Awesome, negative 1. Now I need to find the sum of our minors. So 5 times 5 times 1 is 25. 19 times 5 times 1 is 95. And 1 times 1 times negative 1 is negative 1. So 25 plus 95 minus 1 is 119. So this is minus 119. What is negative 1 minus 119?
Negative 120.
Negative 120. All right, lastly, we need to find d sub z. So what do I have to do differently for d sub z?
Put the answers in the third column.
Put the answers in the third column. So negative 1, 5, and 19 goes in the third column. The first two columns stays the same as our original. So the x coefficients and the y coefficients. So we have 1, 1, 5, and 1, negative 1, 1. What do we have to do to find the determinant? What do we do first?
Rewrite the first two.
Rewrite the first two columns. So we have 1, 1, 5, and 1, negative 1, 1. So we need to find the sum of the majors. So we have 1 times negative 1 times 19, which is negative 19. 1 times 5 is 25. And negative 1 times 1 is negative 1. So what is negative 19 plus 25 minus 1? Five. Now we have the sum of our minors. So 5 times negative 1 times negative 1 is positive 5. 1 times 5 times 1 is positive 5. And 19 times 1 is 19. So 5 plus 19, 29. And what's 5 minus 29? Negative 24.
Negative 24.
So that's our d sub z. So now our answer, we just have to put our d sub x over d, our d sub y over d, and our d sub z over d. So our d sub x is 120 over 24. Our d sub y is negative 120 over 24. And our d sub z is negative 24 over 24. Can we simplify these? Z simplifies to negative 1. Let's see if 24 goes into 120 evenly. Oh, how nice. It goes in 5 times. So we have 5, negative 5, and negative 1. So this is our answer. You will have one of these on the test. All right, let's look at the second question. So it's given matrix A, matrix B, and matrix C. Find the following or explain why the operation cannot be performed. So we have 2 times matrix A minus 4 times matrix B. Could we subtract matrix A and matrix B, these two? Can we subtract them together?
No,
No, why not?
because they're not the same dimensions.
They have different dimensions, so not possible. What are the dimensions of matrix A?
Two by 3.
Awesome, 2 by 3. What are the dimensions of matrix B?
3 by 2.
3 by 2. All right, let's look at A times C. So what are the dimensions of matrix C?
2 by 3.
2 by 3. Can we multiply a 2 by 3 times a 2 by 3?
No,
No. Why?
they don't have the same number in the inside.
The inside number's not the same, so not possible. So in multiplying, you don't need them to be exactly the same, you just need the inside numbers to be the same. All right, can we subtract A and C? Are they the same dimensions?
Yes.
Yes. So let's find 3 times matrix A. So we are just multiplying everything in matrix A times 3. So we just have to distribute the 3 to everything. So what would our new first row be?
-9, -3, and 0.
-9, -3, 0. Awesome. What's our new second row?
6, -15, and 12.
Perfect. So that's 3 times A. Now we can move on to 5 times C. So C is -2, 1, -3, 6, -5, 2. There's 2 ways we can do this. We can multiply -5 to everything in our matrix, or we can just multiply 5 to everything in our matrix and subtract that matrix from A. I like to multiply everything times -5 and then just add the matrix together. But you can do it either way. You can multiply by +5 and then subtract them, or you can multiply by -5 and add them. So let's multiply everything by -5. So what would our new first row be? (10), -5, +15. And our new second row would be -30.
-30, 25, and -10.
Awesome. Now we just add our 2 matrices together. Alright, and remember to add, we just add the first spot with the first spot, second spot with the second spot. So just again, be careful when adding. So what's -9 plus 10? (1). What's -3 plus -5? (8). 0 plus 15? 15. What is 6 plus -30? Thank you, -24. -15 plus 25?
10.
10. And 12 plus -10?
2.
2. So this is our answer. Alright, next one, A times B. So our dimensions of A, we said were 2 times 3, 2 by 3, and B is 3 by 2. Can we multiply these together? Yes, because
Yes.
our insides are the same. What is our answer going to be? What size? What's the size of our answer? A 2 by 2. So the outside numbers give you the size of your dimensions for your answer. So we're going to have 4 numbers in our answer. So I'm just going to rewrite the matrix here. So we have A, which is -3, -1, 0, 2, -5, 4, and B is -1, 3, 2, -4, 5, 8. All right, how do we multiply matrices together?
You multiply the rows by the columns.
Awesome. In the first one, we move in rows. In the second one, we move in columns. So we're looking at our first row times the first column. And remember, you just multiply the first number times the first number, then the second number times the second, and plus the third number times the third. So -3 times -1 gives us what? 3. Then -1 times 2? -2. And 0 times 5? 0. What is 3 minus 2 plus 0? 1. Next, we're looking at the first row, second column. So it's -3 times 3. -9. -1 times -4? +4. And 0 times 8?
0.
So it's -9 plus 4 plus 0?
-5.
-5. All right, where do I go next? second row, first column. What do I multiply together first?
Two times -1.
2 times -1, so that would be -2. What's next? -5 times 2, which would be -10. And then 4 times 5, which is +20.
20.
So what's -2 minus 10 plus 20?
8.
8. Awesome. And then what's last? Second row, second column.
Second row, second column.
So what do we multiply together first?
2 times 3.
2 times 3, so that gives us 6. What's next?
Then 20.
Then 20. And then
32.
32. So 6 plus 20 plus 32?
58.
58. So this matrix is our answer. All right, so determine if B is the inverse to A, show your work. How do we prove that B is the inverse to A? What do we do? So we multiply A times B. So just to prove that they're inverses, we have to multiply A times B and B times A. And when we multiply them, we need it to be the identity matrix. So 1, 0, 0, 1, 1, 0, 0, 1. So let's multiply A times B. What are the dimensions of A? A 2 by 2. Awesome. What are the dimensions of B? A 2 by 2. Thank you. So how do we multiply A times B? What do we do first? So in A, are we looking at the rows or the columns? Remember, in our first one, we move in rows. The second one, we move in columns. So we need to multiply the first row times the first column. So it's 5 times 2. 10. And 3 times -3? -9. So it's 10 minus 9. 1. Where do we go next?
And first column.
So if we do the second row, first column, just keep in mind that that's going to go in the second row, first column spot. So 3 times 2, 6, and 2 times
6.
-3,
-6.
and 6 minus 6, 0. All right, where should we go next?
First row, second column.
First row, second column. So we have 5 times -3, -15, and 3 times 5, +15. So -15 plus 15, 0. All right, what's last?
Second row, second column.
Second row, second column. So -3 times 3, -9, and 2 times 5, plus 10. What's -9 plus 10? 1. So is this our identity matrix?
Yes.
Yes. But we still have to multiply b times a just to prove that they are inverses. So we have to do the same thing, but b comes first. So 2, negative 3. Hi. So I'm just rewriting it. That way b comes first and it's easier for us to multiply. 5, 3, 2, 3, 2. Alright, to multiply these. In our first matrix, we move in rows or columns for multiplying. How do we multiply? The first one we move in rows, the second one we move in columns. So where do we go first?
First row, first column.
First row, first column. So 2 times 5 is 10.
10.
Negative 3 times 3. Negative 9. 10 minus 9.
1.
1. Where do we go next? First row, second column. So 2 times 3. 6.
6.
Negative 3 times 2.
Negative 6.
Negative 6. We get 0. What's next? Second row, first column. Negative 3 times 5. Negative 15. And 5 times 3?
15.
15. So negative 15 plus 15? 0. And what's left?
0. Negative 9 plus 10.
So second row, second column gives us negative 9 plus 10, which is 1. Did we get the identity matrix? Yes.
Yes.
So are these inverses? Is B the inverse to A?
Can you please send over your attendance?
How do we find the inverse to the matrix? Anybody remember?
You do the major and the minors.
What do we do to the majors? Switch them. What do we do to the minors? Make them negative. And then what do we have to multiply once we do that?
No. I forgot.
A times D minus B times C. So when we switch the majors, we just move their position, so the 2 goes into the upper left-hand corner, 5 goes down to the bottom. The minors stay in the same spot, we just have to make them negative, so negative 1 and negative 4. And then we need to find what A times D is, so what's A times D? 5 times negative 2? 10. And B times C? 1 times 4? 4. What's 10 minus 4? 1/6. And then we just have to multiply 1/6 to everything. So what's negative 2 times 1/6? Thank you. Negative 1/3. What is negative 4 times 1/6?
Negative 2/3.
Negative 2/3. Negative 1 times 1 over 6.
Negative 1 over 6.
Negative 1 over 6. And negative 5 times 1 over 6.
Negative 5 over 6.
Negative 5 over 6. So this is our inverse. And we would say it's the inverse by saying it is, if this was matrix A, this would be A to the negative 1 power. So that's just how we name the inverse.